All right, so we are moving on to Unit 2, Lesson 3, more about constant of proportionality, or the COP. Today we are going to solve more problems involving proportional relationships using tables. So we're going to continue with those tables. So our first activity is use the numbers and units from the list to find as many equivalent measurements as you can. And they give us an example of 30 minutes and half an hour. So I would like you to stop the video and go ahead and give it a try and see how many you can get, and I'll give you a couple after you come back. All right, so we could have 12 inches is 1 foot. What else did I come up with? 60 minutes is 1 hour. How about 50 centimeters is half a meter? Let's see, 40 inches is 3 1/3 feet. I bet you had a hard time with that one, didn't you? Actually, I had to look it up. Okay, 0.01 meters is 1 centimeter. We did that one. How about 30 minutes is half an hour? Didn't really come up with one for that. Hopefully you did. There are 24 hours in one day. Do we have days on here? Oh, no we don't. All right, let's take that away. There are 24 inches in 2 feet though. Do we have 2 here somewhere? Yes. Okay, make that 24 inches in 2 feet. All right, so let's see if you can get all of them. All right, so there is a proportional relationship between any length measured in centimeters and the same length measured in millimeters. So if here's a ruler and centimeters is up here and millimeters is down here, and look, there is a relationship between them. So there are 2 ways of thinking about this proportional relationship. We can think of it going this way, or we could think of it going this way. So that's what we're going to do with these tables. So in the first table, if you know the length of something in centimeters, you can calculate the length in meters. Well, let's go back over here and look. 1 centimeter is equivalent to 10 meters. Millimeters. 1 centimeter. So 1 centimeter is equivalent to 10 millimeters. Oh, well, what if I do my y over x like we were doing yesterday, and that would give me a 10 over 1, which means I am going to multiply each of these by 10 because I'm going this way. So that would be 90. Multiply this by 10 by our constant of proportionality, which is this 10 over 1 is our COP. Okay, so that's going to give me 125 times 10 is going to give me 500, and times 10 is going to give me 884 9/10. All right, so we completed the table, and when we did that, we already talked about what is the COP. So the COP equals 10. Okay. All right, so now it says if you know the length of something in millimeters, you can calculate its length in centimeters. So if we look at this, if we know 1 millimeter is going to be 1/10 of a centimeter. Let's go over there and look at this. 1 millimeter right here is 1/10, because this is going to get split up into tenths. So that corresponds to 1/10. So that's where I got that 1/10 from. So now if we do our y over x again, That's going to give us 1/10 over 1. 1/10 divided by 1 is 1/10. And that is our COP. Whoops, I'll put that so you can see it. All right, so now we're going to fill in the table. So we are going this way now. So we are going to multiply this by 1/10, and that's going to give me 7. We are going to go this way. So we're multiplying by 1/10. That's going to give me 24.5. Multiply this by 1/10. That's going to give me 0.4. Multiply this by 1/10. And that's going to give me 69 91/100. All right, so we completed the table and we found our COP was 1/10. So how are these two constants of proportionality related to each other? So let's look at this one and this one. Are they reciprocals of each other? And that kind of makes sense because we're going from centimeters to millimeters, and then we're going centimeters to millimeters back that way. We're going millimeters to centimeters. So it makes sense that it would be the reciprocal. So to convert centimeters to millimeters, you can multiply by 10. To convert millimeters to centimeters, we can divide by that same 10 or multiply by its reciprocal, which is 1/10. Because dividing by 10 is the same thing as multiplying by the reciprocal. All right. So let's look at this. Are you ready for more? I thought this was kind of interesting. How many square millimeters are there in a square centimeter? So let's draw a picture. Here's my centimeter. 1 centimeter by 1 centimeter. So this has an area of 1. Now, if I was to draw that same figure, but now this is 10 millimeters because there are 10 millimeters in a centimeter, and 10 millimeters here. So this is going to have an area of 100 millimeters squared. And this is centimeters squared. I left that out. So how many square millimeters are there in a square centimeter? There are 100. How do you convert square centimeters to square millimeters? You multiply by 100. How do you convert the other way? We're going to multiply by 1/10. I mean, not 1/10, 1/100th. The reciprocal of it. Okay? All right. Next activity. A plane is traveling at a constant speed, flew over Pittsburgh, St. Louis, Albuquerque, and Phoenix on its way from New York to San Diego. All the way across the United States. Complete the table as you answer the questions. Be prepared to explain your reasoning. So we were told that it is flying at a constant speed. In 1 hour, it flies 550 miles. Now, the speed is going to be that y over x that we have done before, because speed is always usually in miles per hour. Well, per means 1, so I have 1 hour here. So that means my speed is 550 over 1, which is 550. So we'll just write that as 550 miles per hour. All right, so that gets us from Pittsburgh to St. Louis. It took 1 hour. St. Louis to Albuquerque took us 1 hour and 42 minutes. And we want to know how far that is. Well, we've got hours and minutes, and all of this was in hours. So we need to convert this 42 minutes into hours. So if we take 42 out of 60, because there's 60 minutes in an hour, that gives us 0.7 if you take out your calculators. So this actually equals 1.7 hours. Well, if we're using the same speed, because they told us it flies at a constant speed, way up here, it said at a constant speed. So that means it has a COP, and that COP is 550. So when we are going this way, we are going to multiply by the COP. So 1.7 times 550 is 935, and this will be miles. And are we still going the same speed? Yes, we are still going 550 miles per hour. All right, we're still doing the same speed because they told us it was constant. We went a distance of 330 miles to get from Albuquerque to Phoenix, and now we were wanting to know how long is that going to take. So we are going this way. So instead of multiplying by the COP, we are going to divide by the COP. Or could we have multiplied by the reciprocal? Yes, because they are the same thing. So 330 divided by 550 is 0.6 hours. And if you really wanted to know what that equaled, we'd multiply that by 60, and that would give us 36 minutes. But you can leave it in hours if you want to. All right, so the distance between St. Louis and Albuquerque. St. Louis and Albuquerque is 935 miles. How many minutes did it take to fly between Albuquerque and Phoenix? Okay, they did ask us in minutes. So that would be 36 minutes. And I got that. Let me show you how I got that. This is of an hour. I'm going to multiply that times 60. And that's going to give me my 36 minutes. All right. On to number 3. What is the proportional relationship represented by this table? Well, in this table, we have the distance traveled is proportional to the elapsed time. Okay? So the distance traveled is proportional to the elapsed, and you could just say time, elapsed time. All right, now Diego says the constant of proportionality is 550. Well, do you agree with Diego? Yes, because that was, Diego is saying that the plane is traveling 550 miles per hour, okay? Andre says the COP is 9 1/6. 9 1/6. This is miles per hour. What if we changed our per to minutes? So how many minutes are there in an hour? Well, there's 60. I'm just trying to see, is there a way to get that 9 1/6? So let's change this to 550 miles in 60 minutes. And I want to make this 1 minute. So I'm going to, what am I going to do? Let's see. I'm going to divide 550 divided by 60. That's going to give me, if I divide that, that's going to give me 1 minute, right? So that equals 9, and let's see, 6 times 9 is 60 times 9 is 540. So that's 10/60ths, and that reduces to 9 1/6. So he got this COP. Is that a true statement? Yes, because Andre is simply looking at, instead of miles per hour, Andre is saying the plane flies 9 1/6 miles per minute. Okay? All right, so both of them were right. So when something is traveling at a constant speed, there is a proportional relationship between the time it takes and the distance traveled. This table shows the distance traveled and elapsed time for a bug crawling on a sidewalk. So if I was to make that y over x, I would end up getting 1 over 3/2, which means 1 divided by 3/2, which equals 2/3. Do I get 2/3 here? 2/3 divided by 1 is 2/3. 2 divided by 3 is 2/3. 20/3 divided by 10 is 2/3. So in this case, my COP is 2/3. So we can multiply any number in the first column by 2/3 to get the corresponding number in the second column. We can say that the elapsed time is proportional to the distance traveled. And the COP is 2/3. This means that the bug's pace is 2/3 seconds per centimeter. All right, this table represents the same situation. But in this situation, if we do that y over x again, we are getting 3/2 as our COP. 1 divided by 2/3 is 3/2. 3 divided by 2 is 3/2. 10 divided by 20/3 is 3/2. So now we have a COP of 3/2. Well, look at the two tables. What's different? This one has distance first, this one has time, this one has time, this one has distance. So does it make sense that the COPs are going to be reciprocals of each other? Yes, it's just a matter of what we're looking at. This one is telling us the pace the bug travels, and the second one is telling us the speed the bug is going. So the bug is traveling at a speed of 3/2 centimeters per second. So notice that they're reciprocals, and when two quantities are in a proportional relationship, there are two COPs, and they are always reciprocals of each other. When we represent proportional relationships with a table, we say the quantity in the second column is proportional to the quantity in the first column. I would probably star these statements here. And the corresponding constant of proportionality is the number we multiply values in the first column to get the values in the second. And that's where we make that y over x. That third column that I keep adding on to it is your COP, your y over x. All right, so I hope you enjoyed today's lesson, and I will see you on Zoom to do some practice problems. Have a great day.